1.8 coordinate geometry. So we're going to start with some basic graphing. We have in the xy plane, we have x is greater than 1. So this is graphing an inequality of two variables, but just with x. So we go to where x is 1, we put our point. We want where all x values are greater than 1, so we put a dashed vertical line through it. And greater than is to the right, so we shade to the right. In the xy plane, we're graphing y equals -2. So we go on the coordinate plane to where y is -2, put a point, and it's equal to, so it's just a horizontal line through it. All points on this line have a y value of -2. We now have a compound inequality in the xy plane where x is greater than -1 but less than 1. So we put points at where x is -1 and 1. It's not equal to, so they're dashed lines and shaded in between. Distance formula. Distance is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And we use this to find the distance between 2 points in the coordinate plane. So if we have 3 points in our coordinate plane, our first point is r at 3, -2, 7, 3, and 5, 2. We want to know which one is closer. Now, sometimes you can tell just by looking at it, but you won't always have a coordinate plane, so we can use the distance formula. We need to do distance of the segment RS So distance for segment RS, we got 5 minus 3 quantity squared plus 2 minus -2 quantity squared. 5 minus 3 is 2 squared plus 4 squared. 2 squared is 4. 4 squared is 16. Add them together, you get 20, which breaks down into 2 root 5. So this is for the distance of our S. If we use TS, five minus 7 quantity squared plus 3 minus 2 quantity squared. Actually, that needs to be 2 minus 3. Goes to -2 squared plus -1 squared. -2 squared is 4. -1 squared is 1. Add it together, we get the square root of 5. Now, because we want which point is closer, we want the smaller distance, which is root 5. So TS is closer, or T is closer to S than R. When you're finding the midpoint of a line segment, you have two points, A and B. You get the formula x1 plus y1, no, x1 plus x2, quantity divided by 2, comma, y1 plus y2 over 2. So there's a great application problem on page 93. It gives you a quadrilateral with 4 points, and it wants to know that its diagonals cross and bisect each other. So it illustrates using the midpoint formula. The graph of an equation in the xy is a set of all points in x, y in the coordinate plane that satisfy the equation. Most graphs we'll encounter this semester will be curves. But let's start with the linear. We have 3x minus 2y equals 6. Let's get it into slope-intercept form. Y equals mx plus b. Subtract the 3x. Get negative 2y equals negative 3x plus 6. Divide by negative 2. So y equals a positive 3 halves x minus 3. Our y-intercept is negative 3. Our b is 3 over 2. Start by plotting the y-intercept at negative 3. And then it's rise over run. So we go up or down first, and then left or right. So we go up 3, 1, 2, 3, and left, right 2, 1, 2. And 1, 2, 3, 1, 2, over. We have our 3 points. It's a solid line because it's not an inequality. There we go. Now we have a quadratic, y equals x squared plus 4x plus 3. We need to find our vertex. Our x value is negative b over 2a. So we take negative 4 over 2 times 1, which goes to negative 2. Now we plug in negative 2 for x and find our y. So we get y equals 4 minus 8 plus 3, so y goes to negative 1. So our vertex is at negative 2, negative 1. So let's start by plotting that, negative 2, negative 1. We know because a is 1, it's positive, we're going to be going up. And then the trick I use is 1a over 1 and 3a over 1. And we kind of treat it like slope. So a is 1, so it goes 1 over 1, so we're going to go up and to both sides 1. So we go up 1, over, and the other way, and we're really reflecting over the axis of symmetry. Now we can go 3 over 1, up 3, and right 1. We have enough to make our parabola. And because we are we solving? No, we're just graphing. Alright, now we come to y equals the absolute value of x. We're going to start this one by making a table. So you're plugging in -2 to the absolute value. It becomes +2, 1, 0, 1, 2. So it turns into a V shape.